Hello everyone, I am Abhishek and today in this video I will talk about remainder theorem and factor theorem. Then I will solve some questions on remainder theorem and factor theorem. Now let us see the first theorem, that is the remainder theorem. So it is saying that if a polynomial fx is divided by another polynomial, a linear polynomial, that is x minus a, then the remainder is f of a. Let us see the proof of this theorem, but before that you need to know about the division algorithm for polynomials, which I already discussed in my previous video. I have given the link of this video in the description box. Also you can check it in the I button. Now according to the division algorithm, if fx is divided by x minus a, then there exist unique polynomials qx and rx such that fx equals to x minus a into qx plus rx, where rx can be a zero polynomial or degree of rx must be less than 1. Now here fx is known as the dividend polynomial. This x minus a is called the divisor polynomial. Qx is called the quotient polynomial and Rx is called the remainder polynomial. Now why degree of Rx is less than the degree of the divisor polynomial, that I have discussed in that previous video. Now let's come back to this point. Here it is given that the degree of Rx is less than 1. And we know that degree of a polynomial cannot be negative. Therefore, there is only one possibility that degree of Rx will be 0. That is, Rx, which is known as a remainder polynomial, is a constant polynomial. Hence, we can say that this remainder will be nothing but a real number. Therefore, we can write fx equals to x minus a into qx plus r, where r is a real number. What? R can be 0 or not? Yes, r can be 0 also. So when r becomes 0, then we can say that x minus a will be a factor of fx. And I have also written that r belongs to the real number set. That is, r is a real number and 0 is also a real number. So r can be equals to 0. Now the question is, if I put x equals to a, then what happens? Definitely, if I put x equals to a, this x will become a. This x will also become a. But there will be no change because r is just a real number. It is not depending on any x. So there will be no change. It's very bad luck for r. Now let us put x equals to a. So after putting x equals to a, we get this relation. But here, after putting x equals to a, that becomes 0. Then we can write f of a equals to 0 into qa plus r. Hence we can write r is equals to f of a. And what was r? That's a remainder. So therefore, if r is equals to fa, the remainder is actually fa. And hence it proves the theorem. That is, if fx is a polynomial and if we divide the polynomial fx by x minus a, then the remainder is f of a. Now the question is it true for any polynomial fx? The answer is yes. Fx can be any polynomial. And what about this divisor polynomial? That is, all the time will it be a linear polynomial? Or it can be a quadratic also, it can be a cubic polynomial also. The answer is, this divisor polynomial have to be a linear polynomial. Or else we cannot convert this remainder polynomial to only a real number. And since we can convert this polynomial to a real number, That is why there was no change here if we put x equals to a. And that is why we can come to this conclusion. So the divisor polynomial has to be a linear polynomial. Now I have two questions. What if the polynomial fx is divided by x plus a? Then what will be the remainder? And the second question is, if I divide the polynomial fx by ax plus b, then what will be the remainder? Since we know that x plus a and ax plus b both are linear polynomials, so this division, this remainder theorem we can apply. Then what will be the remainders? Let's see what will be the remainders. Now in the actual theorem there was minus here, so we need to bring a minus in this place. Since we can write x plus a as x minus of minus a, then the remainder will be f of minus a. Hence the answer of the first question will be f of minus a. Now in the second case, fx is divided by ax plus b. That is, fx is divided by a into x plus b by a. So here we have taken a common. So therefore, using the result of the first question, we can say the remainder will be f of minus b by a. But I can give you a shortcut trick to find out what will be the remainder. You can do it on the rough. To determine that, you can put the divisor polynomial equals to 0 and try to find out the value of x. That will help you to find out the remainder. Let's see. In the first case, the divisor was x plus a. Now if I put x plus a equals to 0, which implies x equals to minus a, hence the remainder will be f of minus a. Similarly, if we put ax plus b equals to 0, which implies x equals to minus b by a, so therefore the remainder will be f of minus b by a. That is how it will help you to find out the remainder. Now let us see some examples. Now if fx equals to x square plus 3x minus 2, and if I divide fx by x plus 1, then what will be the remainder? The remainder will be f of minus 1, which is giving the value of f of minus 1 equals to minus 4. Hence the remainder will be minus 4. Now if fx equals to 3x square plus x plus 1 and the divisor polynomial is 3x plus 1, then the remainder will be f of minus 1 by 3, and which will give the remainder as 1. Now if fx equals to x cube minus 3x plus 2 and the divisor polynomial is x, then what will be the remainder? It's very simple. Put the divisor polynomial equals to 0, so we are getting x equals to 0. Hence the remainder will be f of 0, and which gives the remainder as 2. Now let's talk about the factor theorem. So the statement of this theorem is like that: if fx is a polynomial and a is a real number, then x minus a is a factor of fx if and only if f of a is equals to 0. I think that you have not forgot the proof of the remainder theorem. So I will use the proof of the remainder theorem to prove this theorem. So it was, if fx is, when divided by x minus a, there exists a unique polynomials qx and rx such that fx equals to x minus a into qx plus rx, where rx can be a zero polynomial or the degree of rx is less than 1, and we have proved that this rx is nothing but a real number, and that real number can be 0 also. Now the question is, when r becomes 0, that is the remainder becomes 0, what happens? When the remainder becomes 0, then the divisor will be a perfect factor of the dividend. But the remainder theorem is saying that fx equals to x minus a into qx plus f of a. Here f of a is the remainder. Now, in this theorem it is given that if x minus a is a factor, then the remainder will become 0. That is, f of a equals to 0. And similarly, or I must say conversely, if f of a equals to 0, then x minus a is a factor of fx. Now since f of a equals to 0, we can also state the factor theorem in this way. If fx is a polynomial and a is a real number, then x minus a is a factor of fx if and only if a is a 0 of the polynomial fx, or we can say a is a root of the polynomial equation fx equals to 0. Now that was the factor theorem. What? You need some example? Okay, let's see. Now here fx equals to x square minus 5x plus 6, and we need to check that x minus 3 will be a factor of fx or not. So we have to put f of 3, we need to check f of 3 equals to 0 or not. So let's see, let's find out the value of f of 3. So we can check that f of 3 is coming 0, so therefore we can say that x minus 3 is a factor of the polynomial fx. Now suppose it is given that fx equals to 3x square plus kx minus 1, and it is given that 3x plus 1 is a factor of fx, then we need to find out the value of k. So immediately after that, what we can write? We can write f of minus 1 by 3 equals to 0. Why? Put 3x plus 1 equals to 0. Now try to find out the value of x. The value of x will become minus 1 by 3. So therefore the remainder will be f of minus 1 by 3, and which will be equals to 0, as 3x plus 1 is a factor. So after putting x equals to minus 1 by 3 in the expression and simplifying that, we are getting the value of k equals to minus 2. You can pause the video to check the calculation. I hope I can make you understand the remainder theorem and the factor theorem. See you in the next video with some examples, with some questions of remainder theorem and factor theorem. Thank you.